Hey Kipsters, if you've been hanging for this long, you now know that this is the fourth and final video. If you just started watching the videos, please make sure you take out the Common Core mock assessment that you took the week before break. It is mock assessment number 1 there. We are going over questions 24 through 30, which I do believe is the hardest part of this mock assessment. So please be sure to stick with me and participate along when I ask you to, okay? Cool. Here we go. We're starting with question number 24. At the coffee cafe, Evelyn purchased 6 pounds of coffee beans. She wanted to take the beans she purchased and split them up such that 1.2 pounds of beans were in each bag. How many bags would she need to do this? You guys know I like to cover up the answer choices. It just keeps me focused more on the question, okay? Sometimes you need them, sometimes you don't. We don't need them. We need our brains. Find the key information in the text. I found that, and that as well is super important, okay? She purchased 6 pounds of coffee beans, and there are 1.2 pounds of beans in each bag. And I hear it again, the word each, or the word every, or the word per. I see that. I'm making a ratio table every time. And what do y'all think, what 2 pieces of information, what 2 units do you think we're talking about in this problem that we should put in the ratio table? Go ahead, call them out. Yeah, if you said something like pounds and bags, that's perfect. And now I look for the information in the problem that has both pounds and bags in it. And I see it right there. 1.2 pounds of beans were in each bag. So check it out. 1.2 pounds in each bag. There it is. I got my 6 pounds of coffee beans. So clearly I'm going to put my 6 there. I'm going to highlight the column that I know. And I'm going to draw my arrow from the column that I know to the part that I know in the other column. And that's 6. So I'm now asking myself, and this is really important, how many 1.2s are in 6? Okay, and that means the same exact thing as 6 divided by 1.2. Once again, this means how many 1.2s fit into 6. Okay, now I can't solve that using that way of writing a division problem, but I can make this look like the in the house form, right? So I'm going to take my 1.2, put it outside the house, put my 6 in the house, just like that. Sorry I changed the color of the decimal point. You'll see why in a minute, okay? Obviously, this is a more difficult problem because you have a decimal in the divisor. And I'm not going to talk about dot and spot. I know at KIPP we say that story. I want you to know how to do it. You take the decimal point and you move it to the right one. And whatever you do outside the house, you have to do it inside the house as well. So if I move that red dot over to there, now it's black decimal point. That disappears, and now I have 12 on the outside. I have to do the same thing on the inside. Now, where is my decimal point? Go ahead and point. Where's the decimal point inside that house? Did you point right there? If you did, you'd be right. The 6 is in the ones place. It represents 6 ones. So if you put the decimal point over here, you've now made it speak a different language, and you can't do that. Okay? So we moved the decimal point 1 to the right outside the house. Now we're going to do the same thing inside the house. I moved to the right and moved over there. The red decimal point disappears, and I add a 0 there. So now this question is the same as 60 divided by 12, which you can count by 12 and not pass up 60. 12, 24, 36, 48, 60. Yeah, that's it. It goes in 5 times. So 6 divided by 1.2 equals 5, which means that 1.2 times 5 gives you 6. Whatever you do to the top, you do to the bottom is right. 1 times 5 gives you 5 is right. Take away our answer choices. There it is right there. Now, y'all know when I do a ratio table, I like to show you them 2 different ways. So you could have made the same ratio table, and instead of highlighting the column that you know, you can also highlight the row that you know and draw an arrow from there to the point that you know in the other row. How do you get from 1.2 to 1? This might be tricky, but it isn't that bad, I promise. It's literally divide by 1.2 because you know any number divided by itself gives you 1. So whatever you do to the left, you do to the right. There you go. And look at that. 6 divided by 1.2, it's right up there. The answer is still 5. Okay, no matter which way you do your ratio table, it's going to work out for you, I promise. Just go one step at a time, read the question carefully. So that was number 24. How many bags would you need? 5 bags. 25. Oh, this one was interesting. Jeremy has 2 7-foot-long boards. He needs to cut pieces that are 14 inches long from the boards. What is the greatest number of 14-inch pieces he can cut from the 2 boards? I'm getting rid of my answer choices. I'm just going to look at this problem. There's some key information here. How much board he has? 2 7-foot-long boards. He wants to cut 14 inches from the boards. And already, and I reread the question, how many 14-inch pieces can he cut from the 2 boards? I'm noticing something. I'm seeing units of feet and units of inches, and I really need to make sure I make them speak the same languages right. But here's the thing. You cannot flip open your reference table and find the inches to feet conversion. You have to know it in your head. How many inches are in 1 foot? Go ahead, call it out. 12 is right. That's why I put my 1 there and my 12 inches down there. It says he's got 7-foot-long boards, so I'm going to put the 7 down here. It says 7 feet. That's where I'm putting it. And this ratio table is not too difficult. Again, highlight the column that you know. Draw your arrow. 1 to 7. How do you get from 1 to 7? Call it out, Kipsters. That's times 7. Whatever you do to the top, you do to the bottom is right. 12 times 7. You can roll out your multiples right there. 12 times 7, I'm just going to tell you, if you didn't multiply it faster than I did, gives you 84. Now, 84 is not the answer. That's how many inches are in 7 feet. And this dude, Jeremy, has 2 7-foot-long boards. There's 1, there's 2. I hope that helps you visualize a little more. But that means each board is 7 feet long, which means each board is 84 inches long, because that's just what we solved for. So there's one board, 84 inches. The other one's 84 inches. And they want to know how many 14-inch pieces he can cut from both boards. So let's add both of those boards together, 84 and 84. As you can probably guess, makes 168. And now you want to know how many 14-inch pieces he can cut from the boards. What operation do you think we're going to do to solve this? What are you going to do with the 168 and the 14? Go ahead, call it out. Yeah, if you said division, you were right. I know a lot of people think, oh, he's cutting, man. It's subtraction. No, but it's how many he can get, how many he can make from the entire board. So how many 14-inch pieces can he cut? How many 14-inch groups can he make? That's division. I'm going to do the division for you quickly. Although everyone can do it, 14 doesn't go into 1. It does go into 16 one time. You could do the subtraction. You'll get 2. Bring down the 8. 14 goes into 28 perfectly 2 times. And that'll get you 12. So he can cut 12. Look at this over here. 12 14-inch pieces from both boards. There's your answer right there. Okay, super tricky problem, a lot of different steps, but I think if you go step by step, it actually makes good sense. Okay, so there you go. That was question number 25, a tricky one. Let's move to 26. Hillary created the ratio table below to help her compare the number of black to white circles. If the ratio remains the same, how many black circles will you have if you have 60 white circles? All right, I see 4 black circles. Oh, there's a 4 right there. I see 3 white circles. There's a 3 right there. Oh, I see a bunch of answer choices that I do not need. What I do need to find is that. There are so many different ways to do this problem, but the most important thing you need to know is that if you're ever trying to find a missing value in a ratio table, you cannot add or subtract. You just can't. You need to either multiply or divide using information from the other columns in the ratio table. So I look below the thing I'm looking for, and I see 60. And I look along the same row, and I'm thinking, how do I get from 45 to 60 without adding or subtracting? And you could do it, but that's not something you could do mentally. Now, maybe if I go back to 3, can I go from 3 to 60 mentally? Yeah, I think I know how many threes fit into 60 because I know how many threes fit into six. How many threes fit into six? Six, not 60. How many threes fit into six? Two. So if I do 3 times 20, that's going to get me 60. See, 3 times 20 makes 60. Whatever you do to the bottom, you do to the top is right. So what number do you think is going to go in that blank? Go ahead and call it out. If you said 80, 4 times 20 is 80. That was not the only way. You could have gone from 30 to 60 and done times 2, and then 40 times 2. You could have gone from 15 to 60 and done times 4, and then did 20 times 4. Okay, the point is that you got to use the other columns to help you out. You can only use multiplication or division. Okay, let me pull away my answers. Hope that it's there. And of course it is. That was number 26. Now on to number 27, probably the most annoying problem on this test. The location of point P is shown on the number line below. There it is. Hey P, how you doing? Which of the following numerical expressions would give you an answer closest to point P? And good God, there's A, B, C, D, and they're all different operations. And we're trying to figure out which one is going to get us closest to point P. All right. Well, first, I just want to figure out what P should be about. And anytime I see a number line and I see two holes, 2 and 3, I'm counting the jumps in between them. 1, 2, 3, 4. Which means the denominator, if I was going to do this in fractional form, would be, it'd be 4. So if I start with 2, what would go there? Go ahead, call it out. If you said that, you were right. It goes 2 and 1/4, 2 and 2/4, which is the same. You can reduce that in your head as 1.5. That's 2.5, sorry. And then 2 and 3/4. Okay? But then I look at my answer choices. I see fractions in letter C, but I also see decimals. So I better make these look like decimals too. So I know 2.5, that's 2.50 or $2.50. Can you call out if you remember what 2 and 1/4 would be as a decimal? Go ahead, call it out. Yeah, if you said $2.25, you'd be right. Then this is $2.50. This is $2.75 or 2.75 or 2 and 75 hundredths. So I'm looking for A, B, C, or D to give me something between 2 and 1/4 and 2.5, or between $2.25 and $2.50. All right, we got to go step by step. This is going to be a pain, but we got to do it. Show some grit. Let's go. Letter A. 1.8 plus 0.056. Man, look at 1.8. Look at the languages it speaks. I got my 1 speaking ones. I got my 8 speaking tenths. This decimal over here, I got something speaking tenths. So the 0 can speak to the 8 and be like, hey, how you doing? But the 5 speaks hundredths, and the 6 speaks what language? Call it out. Right. So now I got this problem. I need them all to be able to speak to someone. I need some. Right now, only the 0 and 8 can speak to each other. But check it out. If I do this, that's a good thing to do because now I got the 0 in the 1's place, and that can speak to the 1 in this decimal over there. So can you please talk to your screen or talk to someone and tell them, what can I do to 1.8? There it is. What can I do to this to make it speak all of the languages that this decimal speaks? Go ahead. No, seriously, talk it out. Do it. All right, stop right there. Did you say something about adding zeros, yes or no? That's good if you did. You'd have to add a 0 there and a 0 there. And doing that makes all of them, all the decimal here, speak all the same languages as the decimal here. And now you can add them up. Real simple. Drop the decimal point like it's hot, do some simple addition. 1.856 is the answer that I got. And now I'm saying, is 1.856 close to letter P? The answer is no way. 1.856 is between 1 and 2. I'm sorry, but letter A is not the answer we're looking for. So we're going to move on and try letter B. 1.02 times 2.3. Line it up like that. You do not need to line up the decimal points when you multiply, because when you multiply, the rules switch up. Now, don't you cry. So just ignore the decimal points for now and do your multiplication like normal. If you want to press pause right now and do the multiplication and see if you got it right, go ahead and do that now. So you can press pause and solve it, but I'm going to go on and solve it now and see if you get the same answer as me. So my first row, when you do the multiplication algorithm, 306. When you move down to your second row, please don't forget to add that 0 there to hold the place when you do the multiplication. And if you do the second row, you'll get 204 with that extra 0. You add them up, 2, 3, 4, 6. But now, we all know that's not the right answer. Can you please talk to the screen and tell them, what do you do? Or talk to a neighbor if you have someone near you. What do you do when you're multiplying decimals? Where do you put the decimal point in the answer? Go ahead. Go ahead and talk. All right, stop there. Now, if you remembered correctly, you should have been doing something talking about putting some numbers here in parentheses. 2 goes there. Why 2? Because there's 2 decimal places behind the decimal point. So what should go in parentheses next to this decimal here? Go ahead, call it out. If you said 1, you were right, and then you move it down there. What should go in parentheses down there? Go ahead, call it out. If you said 3, you were right, which means you slide, slippity slide. It's time for the decimal to take a ride. I said once, twice, 3 times. So now we get an answer of 2.346. Watch me move it all the way over here. 2.346. I'm thinking, could that be letter P? Maybe it could, because 2.346, if I put that is about $2.35 or $2.34, because the 6 in the thousandths place is basically worth very little, nothing when it comes to coins. That could be the answer. I better check my other ones, though, to be sure that nothing's closer. Let's move to letter C. 1/2 divided by 1/5. We've done a lot of division problems. The technique we use is keep, switch, flip. I'll keep the 1/2. And by the way, there's other ways to do it, but this is probably the most popular one. I change the division sign to a multiplication sign is right. I do the reciprocal of 1 over 5, which is, call it out. You said 5 over 1, you were right. You could shoot. The numerator would be 1 times 5, which is. The denominator would be 2 times 1, which is. That'll give you 5 over 2. A little get off my back. Division right there. Give you 2 with a remainder of 1. Same as 2.5. Huh. So 1/2 divided by 1/5 is 2.5. 2.5 is right there. You know what? That's pretty good. I do think this one's closer, but there's 2.5, and we'll keep it there. Let's just try letter D. Let's see what's going on with letter D. 11.5 divided by 0.5. Now, you know when I'm doing the straight up division, I like to put these decimals in the house and out the house. So remember, the crisscross way, you take your 0.5, that goes outside the house. Take your 11.5, that goes inside the house. And this is dot and spot again. We just did a problem like this. Whatever, you have to move your decimal point to the right. And however many times you move it to the right outside of the house, you move it to the right inside the house. I have another video that talks about the explanation why, but right now we're just trying to solve it because this is a long problem. I'm getting tired. Come on, let's go. Move to the right once. There's your new decimal point. Goodbye to the whole decimal point. Move it to the right once. There's your new decimal point. Goodbye to the old decimal point. This problem has now become 115 divided by 5. You could do the math on the side. I'm telling you straight up, it's 23. 23! Yo, this is 1, 2, 3. Yo, 23 is, I don't even know where it is, but it's far off this number line. That answer's crazy. So now I'm down to B and C. And I think it's no contest at this point. 2.5 is right here. 2.346. Probably somewhere in there. That one is the closest answer. A lot of work for problem number 27. A lot of grit. But you knew how to do it. You just needed to take your time and think. 27 is done. Moving on to 28. Let's check it out. Stickers. All right, Joshua had a sheet of stickers shown below. What would he have to do to make the ratio of stars to smiley faces 2 to 1? All right, now here's the thing. We cannot put anything over, we can't block these answer choices. We actually need to use them and check to see which one actually will make a ratio of 2 to 1. That's the important part of the problem. Okay, first, before we do anything, let's see what the heck the ratio is right now. So why don't you go ahead and count the stars for me and count the smileys for me and tell me the ratio of stars to smileys. Go ahead and do that now. All right, how many stars did you count? Call it out. All right, how many smileys did you count? Call it out. You got a current ratio of 14 stars to 8 smileys. If you did, you're right. But now we got to make it, we got to do A, B, C, and D and see which one's going to give us the ratio of stars to smileys from 2 to 1. So let's start with our current ratio. There it is. Now, if we take away 1 star, which is what letter A says to do, the 14 is going to become a, no, seriously, if you take 1 away from 14, what's it going to become? Call it out. 13, right. And does the smileys change? Nope, it stays the same. 13 stars to 8 smileys if you do what happened in letter A. Now, does that equal 2 to 1? No, you can't reduce that or anything. It's just 13 over 8. That's not even reducible. That's not the answer. See ya. Let's try letter B. Go back to our current ratio. That's what we started with. If you add a smiley, well, the 8 is now going to become a 9 is right, and the 14 is not going to change. 14 stars to 9 smileys. Yeah, that doesn't reduce to 2 to 1 either. That's not going to work for us either. See ya. Take away 1 smiley. All right. If I take away 8, it's now going to become a 7. Nice. And the stars stay the same. 14 to 7. Can I reduce that? I can. Divide the top and bottom by 7. 14 divided by 7 is going to give me 2 is right. 7 divided by 7 gives me 2 stars to 1 smiley. I think that could be it. I don't want to get too happy. I'm going to keep that up there, though. I'm going to try my last one, letter D. Same ratio I started off with, 14 to 8, 14 to 8. Take away 10 stars. I take away 10 stars from 14. That's going to leave me with 4 stars and 8 smileys. Can I reduce that? Can I do 4 and 8? Reduce 4 eighths? Yeah, I can divide the top and bottom by 4. That's going to get me 1 star to 2 smileys. Oh, interesting. But the question said stars to smileys is 2 to 1. That's 2 to 1. That's 1 to 2. Letter D is wrong, and letter C is the right answer. So you see, for this problem, you need to go through each one and see what would happen to the ratio if you did what it told you to do. And only one of them gave you an answer of 2 to 1. Okay? Tricky question, but kind of fun. Let's move on to 29. Man, do I love this problem. Looks all freaky, is really simple. The product of what 2 factors would recreate the dividend in the division problem shown below? And then shows a big Badonka division problem. And then you actually need these answers. Okay? We can't block them. We actually need to look at them. But here's the thing. First and most important thing, what the heck is the dividend? Can you point in this division problem up here? Can you point to where the dividend is? Go ahead and point. If you pointed there, you were right. Now, what is this question asking? It's saying the product. Product means to do what operation? Call it out. Multiply is right. So if I multiply what 2 factors or what 2 numbers could I multiply to get this? That's what the question's saying. What 2 numbers can I multiply to get 3,024? Now let me look at my answer choices. Yo, what 16 and 3,024? If I multiply them together, am I going to get 3,024? No way. That's way too big. And the other one that's too big is letter C. 189 times 3,024. Yo, 1 times 3,024 is 3,024. 189 times 3,024 is going to be huge. So now I'm left with B or D. And look, you could do the multiplication if you wanted, but if you remember, and you've done this before, the quotient, number on the top, times the divisor, plus the remainder, but there is no remainder, you see it down there, gives you the dividend. The answer is simply letter B. The quotient times the divisor plus the remainder gives the dividend 189 times 16. You could do it on the side if you want, but this is an example of you needing to know that you take the quotient times the divisor, add the remainder if there is one, and you're going to get the dividend. That was question number 29. Not too difficult, to be honest. Okay? Now you know it. Don't mess it up again. And the last one, question number 30. The weight of a nickel is 5 grams. How many milligrams do 3 nickels weigh? Let me get rid of my answer choices. All right. I see the weight of a nickel is 5 grams. I see something about 3 nickels. This whole problem has important information in it. So let me just start of the weight of a nickel is 5 grams. All right. So I could make a ratio table just with the nickels and the grams. 1 nickel, 5 grams. Kip says, how many nickels am I talking about in this problem? Go ahead and call it out. Yeah, it's 3 nickels. This is an easy ratio table. Highlight what you know, draw the arrow from what you know to the piece of information in the other column that you know. How do you get from 1 to 3? Go ahead and call it out. That's a times 3. Whatever you do to the top, you do to the bottom is right. 5 times 3, 15. We're done. Woo! No, we're not. Y'all didn't think this problem would be that simple. Go ahead and tell the screen or tell your neighbor, whoever's around you, why are we not done with this problem? Go ahead and talk. All right, stop. Now, do you realize if you talk to your neighbor or you talk to your screen, you said something about the question I just solved for grams, but the question said milligrams? Then you were totally right. But you're thinking, Negron, look, I don't even know how to go from grams to milligrams. Y'all, first of all, you have a reference sheet. And we talked about this once before. There is a piece of information on this reference sheet that you can use. And some of you know this by heart, which is great. But use the reference sheet just to make sure. Can you point on the reference sheet the conversion that's going to help you solve this problem? Go ahead and look. Point now. Did you point to this one? If you did, you were right. And if you know that piece of information, we're going to be able to solve this problem in like 1 more minute. We need to go from grams to milligrams. And based off of this conversion sheet, 1 gram is 1,000 milligrams. Now, I'm going to take the piece of information I solved for on the other ratio table, which is 15 grams. I'm going to put it up there because grams is now up there. Okay, and now I just have to solve. Highlight the column that I know, draw the arrow. How do I get from 1 to 15? Call it out, please. Times 15 is right. Whatever I do to the top, I do to the bottom. 1,000 times 15. That's a scratch and match situation right there. That's 15,000. How many milligrams do 3 nickels weigh? The answer was 15,000. If you've been with me this whole time, thank you so much. Hope you got a little bit smarter. And I hope y'all are enjoying your break as always. Just give me a call if you need help with anything. And thanks for listening.